Well, how are you doing? This video is going to be titled 0 degrees horizontal. So I'm going to cover two things in this and they are going to cover a lot, but these two things are very basic. They're just rules of geometry, I suppose. Okay, here we have horizontal lines, we have vertical lines, we have oblique lines, we have perpendicular 90-degree angled perpendicular lines, and we have parallel lines. So I'm going to be talking about 0 degrees horizontal and parallel horizontal lines. 0 degrees horizontal can't be violated. What I mean by that is if you have a 0 degrees horizontal, you can't change that position and make a new 0 degrees horizontal unless it's parallel to the old 0 degrees horizontal. It has to be absolutely parallel. You can't change 0 degrees horizontal to be a different angle. 0 degrees is the center of all degrees, as in that are above and below it. So you can't change your 0 degrees horizontal to a different 0 degrees horizontal when it suits it. But on our opposition side, they claim to be doing this all the time. Now, they don't outwardly make the claim that they're violating 0 degrees horizontal, but it's implied in their claims that they make anyway. Now, nowhere do we see this more than with aircraft and flight, because with aircraft and flight, I'm just going to show here, right? You have a situation where they have a 0 degrees horizontal, right? They take off and they have 0 degrees horizontal. They get to a point at cruising altitude where they are using a 0 degrees horizontal. Now, they in the real world will fly for at least 99% of that flight with the chord line of the airplane wings, and by proxy the nose of the the nose of the aircraft, several degrees above horizontal, right? So how do they know that they're flying 3 and 4 degrees, which for commercial I'm going to use commercial airliners as the example because they fly the largest distances. And they spend more time moving in a straight line than any other aircraft, because the smaller aircraft do all kinds of aerobatics that the bigger airlines don't do. So they establish that they are going an average, let's say if they're flying with a commercial airliner is flying a Boeing 747 or something with a 3 to 4 degree plus pitch. So the nose would be 3 to 4 degrees above 0 degrees horizontal. This is how they fly. And they do this for thousands of miles. They may change their altitude in accordance with the ground and sea below them, here and there. But they're not changing. They're not changing. When I say they're changing their altitude, that'd be more because they're going to follow an air pressure. So when you're flying, you're going to run into because we have all kinds of convection cells, especially at the equator. There's convection cells, the Hadley convection cells, because the equator region gets the most amount of direct sunlight. They have the most amount of low pressure at the equator line, so they have more rising warm air. So that is obviously going to be, if you're holding a particular air pressure as your baseline, then when you're flying into that kind of a situation from let's say winter time in Europe, then you're obviously going to have to maybe change your altitude a bit to fit, because you're flying into a situation that's a little bit different from the situation you flew out of. So if you're flying from Europe and you're heading over the equator line, then you're going to have to make altitude changes, I would say. because you're going to be dealing with more convection and different things like that. But either way, right, that's only a case of how high above the surface of the earth the base of the airplane is, right? But your the chord line of the wings and the nose will always be, of these commercial airliners, they'll always be 3 to 4 degrees above 0 degrees horizontal. So here, if we treat, let's say, these horizontals here, this is just above the ground, this lower one here. This one here is 1 mile up in the sky. This second one here, or third one I should say, is 2 miles up in the sky, 3 miles up in the sky, 4 miles up in the sky, 5 miles up in the sky. So they're all horizontals. They're all 0 degree horizontals, and they're all making parallels to each other. But when are horizontals not parallel to each other? Because our opponents are claiming not only that they violate 0 degrees horizontal, but that the horizontals then would not be parallel to each other. You can have all kinds of horizontals as long as they are parallel to each other. They must be parallel, either laterally or vertically. They have to be parallel to each other. That's what they are. Because when one of these is not parallel to the others here, if any one of these lines here is not parallel to the rest of them, then it's not a horizontal anymore. If you tilt, let's say, this one here, this side of this one down, and tilt this side up, it's not horizontal anymore. It's not a horizontal line anymore. It stops being a horizontal line. So horizontal lines, 0 degrees horizontal, cannot be violated. Number one. And number two, horizontal lines always, either laterally or vertically, always have to be parallel to each other. These are just rules of geometry. It's just the way it is. So if you can imagine, these four here are 4 different aircraft, 2 flying to the left and 2 flying to the right, and are going to different locations. But each one of them might be at a different altitude, but they all have to follow a 0 degrees horizontal. They all have to do that. So I'm just going to minimize this slightly. And I'm just going to go down to here. Okay, this is a graph, right? It's a lift graph, angle of attack here, right? AOA, right? Now, you have 0 degrees horizontal here, or sorry, 0 degrees here, right? That goes up to plus 30 degrees and down to minus 10 degrees. Now, most airfoils, which is the wings, right, at this point of 0 degrees, they lose all positive lift, right? All. But there is one type of wing, a cambered airfoil, cambered wing, that will hold a certain amount of positive lift, right, below 0 degrees. But what they mean there is, and our opponents, right, get this wrong, and I've had this presented to me 2 times, right? Our opponents think that the airfoil can be minus 5 degrees below 0, and the plane is still holding full positive lift. No, this is the nose of the plane, okay? And the nose of the plane can pitch down, right, with a cambered airfoil, can pitch down minus 2 degrees and still have enough positive lift to hold it in the air somewhat. But when you're minus 2 degrees, you are then in a descent, because 0 is your baseline. So when you're minus 2 degrees, you're then basically flying in. You may not be in a direct descent if you're holding some lift, but you are in the direction of descent, right? Let's just say. But the thing about that is, our opposition, when this was presented to me twice. What they didn't understand is that, yes, you do have lift when the nose with a cambered wing, when the nose of the aircraft is about 2 degrees below, right? But this is not something that pilots do on a regular basis. This is like theoretical. You can do it. It's something that can be done, but it's not efficient. You're not going to fly thousands of miles like that. You're not going to fly 10 miles like that, because what's the point? Unless you absolutely have to because of weather or your thrust. If you add a lot of thrust, you must bring the nose of the wing or the nose of the airplane down. When you go slower, you bring it up. When you go faster, you bring it down, because thrust generates lift. So you have to counter the lift with your thrust. When you add thrust, you have to counter the lift by pushing the nose down. And when you are not moving very fast, you bring the nose up, so that maintains lift. So when they're coming into land, airplanes, when they come into land, the nose is always way up in the air, but they come in slow, right? That's how they can. The reason that it's up in the air like that is that they hold lift. They hold lift while going slow with the nose of the airplane, and the chord line. It's based around the chord line, the angle of attack. The chord line up at I don't know if it's 10, 15 degrees or something like that when they're coming into land. But this thing here, at -2 degrees, the chord line would be still only touching the zero or around the zero. So the chord line would still, like the plane would still have lift, but it wouldn't have 100% positive lift at that point. It would still have lift, but it wouldn't have the same amount of lift as when the nose of the airplane is brought up towards zero and above. It won't have the same amount of lift, but it will still have lift. Now, our opposition, those who presented this to me, thought that this meant that at -5 degrees, with the wings -5 degrees below horizontal, or below 0 degrees horizontal, that the aircraft will still have lift. No. At -2, because I even looked online and on different forums about this thing, and it's kind of like a question that's asked by newer pilots, the people who are more experienced, and the average was, everyone was saying, well, it was 2 degrees. That's what I found. At 2 degrees is like the max is 2 degrees. Do you know what I mean? You're not going to hold up. So after that, the amount of positive to negative lift will change dramatically from -2 degrees to -5 degrees. So they're not flying around the world with the chord line of the wings at -5 degrees horizontal. That's not what's happening. The nose of the airplane can be -2 degrees with a cambered wing, and they'll still hold a certain amount of positive lift. But if they're going to go anywhere, and that could be when they're adding a lot of thrust, let's just say. But if they're going to go anywhere at any kind of just a normal cruising speed, they're going to, at any distance, they're going to have because they have to have the chord line of the wings and the nose above horizontal. That's how they fly. And just to support that, I'm just going to show. Right, here is right. They're just here is a climb. Right, it'd be +8 degrees. Right, this is the chord line of the wings. This is a climb. This is level. Right, they have it at +6 degrees. It depends on the plane. Might be maybe smaller planes. Would have it at +6. Right, this is level, flying at level, and as you can see, this is 0 degrees horizontal here, and the +6 degrees, which is +6 degrees above 0 degrees. So this is when they're flying level flight, what they call level flight, right? Horizontal, level, right? They can't violate 0 degrees horizontal. -8 degrees here, I think it's -8, or it looks like -8, is descent. There is a full descent here, right? So they're showing this is a climb. This is a level flight when they're flying straight, right? They have their chord line above 0 degrees horizontal, and the nose, right? It's going to be, and the nose, it depends on the plane and the angle of the wings to the nose of that particular plane, and it was made. Like the B-52 bomber can fly with its nose, and often can fly with its nose down, but the chord line of the wings still are going to be above, still going to hold lift because it's going to be above 0 degrees. So it's about the chord line more than the nose, right? So the chord line has to be above 0 degrees horizontal to hold positive lift to fly level at cruising altitude, right? For a descent, obviously, the chord line is going to be below 0 degrees horizontal, and for a climb, it's going to be a good bit above 0 degrees horizontal, right? So then we come to these level low speed, right? This is when they want to fly in a straight line, but they want to fly slow. So you have it at +12 degrees, right? Because the slower you fly, the less lift you're generating. If you have the wings at a normal, the chord line at a normal degree above zero. So this is like when they're coming into land, they're going to start having the chord line and the nose, because the nose is part of the plane, way up above 0 degrees, because that's how they do it. They come in slow and they keep the plane in a pitch, kind of an extreme pitch up. without going too far because they'll go into a stall. So they have a good pitch up so they can fly in slow. So they basically just kind of nearly hover in if you watch them. They nearly hover in, some of the really good pilots. And they come in and it's really smooth the way they do it. Then you have level cruise speed, which is here, where the chord line is about, they show here 6 degrees. As I said, for a commercial airliner, I think it's 3 to 4, but they could be a bit more. But these might be more for a smaller airplane, because I see a lot of small airplanes, they fly at more of an angle. Up the way, more of a positive angle up with the wings. So this is if they want to go in a straight line, they're going to be 6 degrees above level cruising speed, the normal speed. Then you have level high speed, right? So this is level low speed. With when they're flying low, the wings are plus 12 degrees. Level cruising speed, which is normal speed, is going to be plus 6, and then you have level high speed. So I reckon this is plus 3. So I reckon this would probably be correct, because even for some of the bigger, no, this probably wouldn't be for some of the bigger ones. It's probably more for a smaller plane. But they have plus 3 degrees here, where the nose of the airplane is brought down to about plus 1, plus 2 degrees, about 2 degrees above, and the chord line's by about 3 degrees above or something like that, where because they're generating lift with the thrust, they have to push the nose down, because the thrust create such lift that the airplane, the nose airplane, wants to go up, which will bring them into a stall. So they have to do that. So that's just the basics of chord line and how it works. This is like there's nothing here showing the airplane flying in any way using the wing here, the airfoil, flying in any way below for any kind of a below 0 degrees horizontal situation. They just don't do that. They can do it, but it's called a descent. As I said, with cambered wing, they can fly with the nose slightly below horizontal, about 2 degrees below, and still hold it with the cambered wing enough positive lift. But that's not something they're going to do if they're going to do it. That would be if they're using a lot of thrust or something. They're not going to be doing that all the time. And it's mostly just a theoretical thing, as I said, that seems to be asked by kind of student pilots to more experienced ones from the forums I looked at online anyway. Here is a comment on YouTube on one of my videos. This Wolfie 6020 made to this other overweight aviator. 2 of these are pilots, right? And never mind, this is like they're talking about the HUD and something that the two of them misunderstand here. So they're saying, oh dear, another spectacular failure of understanding. It's about me, actually. It demonstrates they have no clue at all how the HUD works, right? This is Wolfie writing this. I have shown video of the nose below horizontal, 2 degrees down in a descent. That's the part, right? So 2 degrees down is a descent, right? And the argument he makes then after that is about the HUD. That's a separate thing. I'll make maybe another video on that. It's just something he doesn't understand. I already sent him a message about that. But the 2 degrees down in a descent, that's the important thing, because this is a commercial pilot telling you that when the nose below horizontal 2 degrees down in a descent, the nose 2 degrees down, the airplane's in a descent. That's the way it is. So if you're so this is obviously in a normal flying at a normal speed, 2 degrees down is going to be a descent, right? So commercial pilot, a very well known one on the Globe side, the most well known one on our opponent side, Wolfie 6020, and he's stating here 2 degrees down is a descent, right? Because it is. Okay, so I'll just read out just the rest of it, because it's not connected to this video. It is connected to it, but not. It's something I could make another video about. And the Earth horizon is still below the HUD horizon line. Don't they know that line has to be 0, because that is the reference? See, there you go, 0, because that is the reference used to determine pitch altitude. So he's stating here that 0 is the baseline. Now, if it moved with pitch adjustments, it would be useless, right? He's stating here that 0 is the baseline. But this comes back to, I may as well just deal with this now. This comes back to an issue, right? his HUD, which is like his artificial horizon on his plane, that you'll see it. It's like a green computer screen that the pilots have up in front of the eye line. That is kept parallel, like that's going to be parallel with the horizon. So I'm just going to go back to here. So if we look at these, right, if this one here, let's say we use this one here, this middle one here, 1, 2, 3 down, that this is Wolfie's HUD, right? Right. He's 6 miles above the Earth's surface. So the horizon line is going to be at least down here, because he's making a parallel horizontal with his airplane flying in a straight line to the ground underneath. But just because the land underneath stretches out more and more in your view as you go higher doesn't mean that you're not above it. So he's flying above something. So how can he expect the HUD, his false horizon, let's just say, that's in his airplane, how can he expect this line here to meet and match with this one? That would be breaking the law of the horizontals not being parallel. Like, it's not going to meet and match it perfectly. It might appear to do so. It will often appear that way. It depends on how much visibility you have and how far away the horizon is at that time. It might appear that way, but the HUD line will always be above. If you're flying normally. Will always be above the ground below it, because not only are you making a parallel with the surface below you, right, which means that's two parallel lines, two horizontal parallels, but airplanes fly with their nose pitched up by several degrees. So not only is he making a parallel with the surface below him, but he's also pitching the nose up by several degrees. So that's why he thinks that what he's writing here is some kind of a debunk of reality. It's like, this means it's not fact. No, he just doesn't understand. And if he just read his own comment, he'd see it. 2 degrees down in a descent, so he's descending at 2 degrees down, and the outer horizon is still below the HUD horizon line. Don't they know that line has to be 0, because that is the reference used to determine pitch altitude? Yeah, but if the plane is flying 3 degrees at an average of 3 to 4 degrees above horizontal, when he pitches it down 2 degrees and he's 6 miles above the surface of the Earth, then the HUD line is always going to be it's always going to look to be a parallel line with the horizon. It depends on the day with the weather and your visibility and how far away the horizon line is, because the horizon is just a visible thing. But it's always going to be the horizon is always going to be only making a parallel. The HUD line will always be only making a parallel with the horizon. That's what will be happening. That's just like, you can't. Anything else would be non-reality. It's just two parallel horizontal lines. That's all it is. So even at 2 degrees down, the HUD line will still, like the HUD line will still be only making a parallel with the horizon, but it won't be like it won't be it won't be below the horizon line, because he'd have to pitch down more for that to happen. He'd have to be really pitched down, like probably 6 degrees, four or five anyway, 6 maybe for that to happen, because he's making a parallel. His airplane is making a parallel, and even though he's 2 degrees down, his airplane, like the HUD line, will still be making only a parallel with the horizon. So I don't see any problem there. I would expect that to be the case with a flat plane. I don't see what the problem is. Now, this is just a claim. I haven't seen him do this, so I'm just taking his claim, and I say, yeah, that would be pretty much okay. Now, I don't know if that really happens, is what he says. So you can't trust him. You can't trust him or any of these Globe pilots. But I'm using him as my witness here, because he is a commercial pilot, and this is what he states: 2 degrees down in a descent, and that the zero has to be their baseline. So, you tell me. So, I'm just going to go to, let me see, back to here a sec. right? This is from Boeing, right? Recovery techniques. Nose high recovery, nose low recovery. I'm not going to read all of this, right? But it's there for whoever wants to read it, right? So this is the recovery of nose high, right, and nose low, right? So this is when your nose is too high, how to recover back to normal level, and when your nose is too low of the airplane, how to recover back to normal level. Look, recover to level flight. So even says here, recover to level flight, right? Right? Because if you can end up in a situation when you're flying, by all accounts, that what can happen is when you nose is too high, you go into a stall. Nose is too low, it changes the amount of positive to negative lift, and you end up with more positive lift on the top. Well, more positive on the top and negative on the bottom, which is pushing you down the way. In a really big, obviously there's a lot of things goes into flying, but the basics of it, it's pushing you down as opposed to lifting you up. So you have when your nose is too low, you're being pushed down the way by the positive pressure. Whereas when you recover, you need to, obviously there's a lot more goes into it than the basics of what I'm talking about, but it's still the same. To recover, you must get that nose coming back. You must get that nose, recover the nose back up, because you're going to be using things like the elevators at the back and different parts of the wings, the flaps and different things to try and make that happen. So this is from Boeing. Read it if you want. I'm not going to read the whole lot because I want the video to be not too long. So here we have, right, this is from a video that Wolfie made in 2016, where he states and shows that I was going to make it bigger. He states and shows that he will have to pitch down to go around the globe, right? So if I show here, there's a different horizontal. So there's his first horizontal. This is 0 degrees. But then when he does that, that's a different 0 degrees. Now, how can you have two different 0 degrees? He just said in a comment that 0 degrees is the baseline. So how can you change from that? Here's another one. Another 0 degrees. Another. 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 And another. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 horizontals. That's what he has to claim. So this is what he's claiming, right? 12 horizontals, right? So for him to fly around the globe, he has to come up with, just in this scenario, 12 different horizontal, 0 degrees horizontals. How do you do that? How do you come up with 12 different 0 degrees horizontals? It's an impossibility. You can't do that. So that's the original 0 degrees horizontal. And he states in his comment that that's his baseline. He can't, that's the baseline. 2 degrees below that is a descent. So technically he's saying that's a descent. He's descending towards the earth there, the surface of the earth. But at the same time, he's trying to say he's going around the globe. That's what he's showing here. Totally contradictory. So he's stating that 2 degrees is a descent. And then he's showing that this is what happens when a plane flies a long distance around the globe. You know, if a plane supposedly circumnavigated the globe, that's what it would have to do, yeah? But how would it violate 0 degrees horizontal? It can't. It's impossible. Unless you want to believe you're doing it. So then you can show this and believe you're doing it. But in reality, you're going to be writing in comments stating that 0 degrees or anything below 0 degrees is a descent. You know, so there you go. So I'm just going to make this one smaller and get this one. So this is from another globe proponent. I think his name is Professor Davidson, but he's not really a professor. He just says he is for YouTube reasons. And his name is not Davidson. It's Dave. So his name is Dave, just a guy called Dave. So he has this thing in his video where he's showing this plane flying around this globe Earth. And he's like, planes maintain constant altitude. Yes, they maintain a constant altitude. What has that got to do with flying around a curved surface? Nothing, right? They have to maintain a constant altitude across a flat plane. right? It doesn't matter. It doesn't prove either. It doesn't prove that you're flying around a globe or you're flying across a flat plane. So this is the only comeback that they've got. That a plane just holds a constant altitude. And it's like to hold, like on a globe, he's trying to hold this constant altitude. Watch. Right, and I go back again. Right, this here would be his initial 0 degrees horizontal, this red line. This black line here is a basic 0 degrees in reality, right? But he's here claiming to be off the side of this globe here, and this is his beginning, let's say from this beginning of this flight, this is his beginning 0 degrees horizontal. So, watch. There's 3 different horizontals, 4, 5, 6, 7, and back. Look, all these different horizontals. How can you have all these different horizontals? You can't. So, right, this, right, is 0 degrees horizontal. This black line here, right, with all the red arrows pointing towards it. So, Professor Dave, well, he's not a professor, he's just Dave, and Wolfie and all these other people, they're all claiming to be flying, that airplanes do this, right, up to here and fly all the way down here, right? But how many different 0 degrees horizontals is that? This is 0 degrees horizontal right here. So if this airplane is going to go here, then it has to completely violate that 0 degrees. How can you have 2 horizontal lines that are not parallel? And how can you violate 0 degrees horizontal in reality, right? I don't care what they say they can do on their globe model. In reality, right, you can't do it. Now, I've asked for the evidence of this. I've requested from Wolfie the thrust data that will support the drop, right? Because to drop in altitude constantly, like you would have to do on a globe Earth, then that would mean a constant change of thrust, right? So to deal with the drop value, you'd have to deal with going around this globe here. That would mean changing of the thrust on a regular basis. Now that would be felt by the passengers. You'd know what's happening. But basically, you have to constantly slow down to drop in altitude, and slow down, just pull back on the thrust, drop in altitude, pull back on the thrust, drop in altitude. So that would deal with the drop, right? So that's only drop. So the thrust data for the drop, but that's only drop alone. That's not the curvature. So for the curvature of their globe, right, I asked Wolfie to present, right, the pitch data, right. So I'm looking for the thrust data for the drop and the pitch data for the curvature, because you need both of them, right? And I looked for him to present it from an official source, and that so that I could get it corroborated. I know people who work in that industry, and they could do that for me. And he refused. So why would you refuse? Because I asked him this privately in comments now over the time, over the years. Why would you refuse to do that? If that is the very thing that would support your claim. Like, what is it? How is it top secret? It's only pitch and thrust data of a commercial flight. There's like in normal circumstances, there's like 10,000 flights happen a day. So why is it a secret? The pitch and thrust data of any of those flights. What's the secret? Why can't you present it? You know, because what you have is Wolfie looking to have nonsense debates with me that have all these caveats and all these things that you're supposed to agree with. You know, it's all nonsense. It's everything is avoiding coming up with that data. So I'm not interested in any time wasting. I'm not interested in any debates with him. He had that opportunity. He wasted it twice. I'm not interested in all that. I'm interested in the presenting of the data. It doesn't have to be him. It can be any pilot who claims that they're flying around a globe. I don't care if it's not Wolfie. He doesn't have to be him, but he has been the one making the main claims on our opposition side. So either him or whoever come up with the data. Otherwise, I have to throw all your claims out the window, because that data would prove, right? It would prove, you'd be able to prove this. But that data would also mean that you'd have to prove that horizontal lines, right, don't have to be parallel, and 0 degrees horizontal can constantly be violated. that you can create a whole new 0 degrees horizontal at a completely different angle from what the last 0 degrees horizontal was. That means you're going to have all these different degrees, 0 degrees, right? That's 0 degrees, right, in the our world. This is 0 degrees. 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 You know, how many different 0 degrees do you need to have? Because this here is 0 degrees horizontal. How do you violate that? How do you violate that? And how do you have horizontal lines that are not parallel? Can't. I know that that is not ever going to turn up. I'm asking for it, but I know it'll never turn up because it doesn't exist. Simple as. Thanks for watching.